When we talk about latency, we really mean two things. For a whole application, we mean if its reaction time is real time or not. For a single memory access, we mean by latency how long it takes. In a classic CPU core, these two things are connected. A slow memory access, which cannot be overlapped with other computation, slows down the application, so the reaction time goes up. Flow's architecture is built to hide latencies through multiple fibers. So, a long memory access can be tolerated as its latency is hidden and does not translate into long application reaction time. So for latency, PPUs have decoupled memory access latency and latency in the application's reaction. And this is, I think, a good thing. So when we switch control from CPU cores to PPU cores by running fibers, there is a certain overhead. However, this overhead is much smaller than the overhead when we start further threads on a classic CPU with multiple cores. The PPU fibers share a large part of their state and they all execute the same code. So the startup time for fibers is much smaller than for CPU threads, and thus going parallel and handing over control to the PPUs will be much faster. As it is much faster, it pays off already for much smaller parts of the code that can be parallelized with PPUs but are not worthwhile to be parallelized on CPU threads, because there the overhead would be too large, giving the small workload.